Okay, so once again, welcome everyone to today's session. So we will be discussing further into the data manipulation with Tidyverse, deep layer and Tidy topics today. Okay, we had a problem, so we will discuss those things in a detailed way. We will be working with the R Markdown file today. So R Markdown is nothing but a Markdown format in R. So Markdown is the format we usually submit for papers and also, or it's a plain text format. So today we will be using that RMD format to create a report in a HTML or PDF or Word format, but we will stick with HTML for now, and even if we needed, we can. mm, Uh, yeah, if we needed, we can actually convert it into PDF or Word as required. So I'm just creating a RMD file here. So for that, we can go to a new file and select the R Markdown. So I'm giving a title and author name is my name, and I'm using the current date, so it will update as per I'm rendering the document again. So if I click on OK, I'll be getting a document in this format. So nowadays, actually, we have a visual option for RMD files. So we can actually uh, enter the things and format things as we do it in a Word or WordPad and all. So we can, even if we don't want something, we can delete it. So whatever is here, this is actually a demo thing. So that will be part of every new RMD files you have taken. And apart from this visual editor, you will be having a source editor as well. So this is the source editor. So here you can see the markdown codes and all. Okay, so we'll be discussing the tropical storm data and how to do the data wrangling of this tropical storm data. Uh, okay, in today's session. So I'll be discussing those things. So okay, so first thing is we need to every time when we go for something, we need to um, load the libraries. Okay, so that is the first thing. And before that, I will paste the I will keep the assignment task here so we can discuss those things. Okay, one by one. Okay, so we already have a format in the problem, so we can use the visual editor to paste the same thing. So okay, so this is a problem. So okay, so the problem is basically the tropical storm data wrangling process. So we need to complete the following task in an R markdown file, and your code must be tidy, well documented, and use the pipe operator, either of the pipe operator. So the task is divided into four parts. First part is actually understanding the exploratory analysis, and okay, first part will be understanding the exploratory analysis. Just explore the data. So this data is part of the Tidyverse environment, and we can load the data set just after loading the package. Okay, and then write a 2 to 3 sentence summary describing the total number of rows of and columns, what one row in the data set represent, and two potential and data quality issues you notice. um, okay, second part is data transformation with deep layer. So first one is filtering and selecting new. We can create new data frame called these things and only include the observation where status is this one and year after 2000, and we can subset the columns or select our needed columns. Then we can mutate the data in your subset, add new columns called wind kilometer per hour that convert wind currently in knots to kilometer per hour. And then summarizing the data, identify the storm of the century for each year since 2010. Calculate the maximum wind speed and minimum pressure recorded for each storm, name with those years. And third one is data reshaping with idea, that is pivoting. If you wanted to compare the distribution of wind and pressure across different storm categories, we can, this is an example, we can use the pivot longer to transform these two numeric column into a single column called metric and their values into column called value. Then third task will be unite, using the unite function. Use the unite function to create the new column called date ID by combining year, month, and day with by day with the hyphen. Okay. Now, fourth one is interpretation and code smell. So, based on the analysis of task 2 and 3, which year have more intensity storm activity, just justify the answer using the data generator and code quality. Okay, these are the basic elementary things we need. So once we convert this one, we'll be having a code will be markdown format will be auto generated. So here, if you can see, there is some dots are actually popping up. So these are unnecessary things. So that we can actually replace. We can select this and replace it. Okay, we can replace it with a space. So replace all, it will be replaced. Okay. So if you go to visual, you will see the same only. Okay, with a proper question. Okay, now let me save this as okay, perfect. So I'll be saving this one. And now, if we have a R Markdown format, then we can go to knit, and if we need to HTML, it will create it in a HTML format. So this is the thing we have just added. Okay, so this is a HTML document. We can even convert it into different format like PDF or Word and all. Okay, that we can do later. Now we'll start with each of the tasks, so it will help us to understand the uh, okay. So there will be headings and all. Headings we usually put using hash. Okay. So there will be header one. For that we need one slash, and up to six headings we can add. The rest of the things we are typing, that will be a normal text. Okay, that will be a normal text, and you can also format it bold, italics, and underline or code part, and you can insert any of these blocks and all if you need uh, in your code and all. Okay, or markdown. So here, okay, okay, let's go for the solution first. Okay, first okay, first loading the library like this. So and load the data as needed. So this is our data. Okay, this is the storm data. Let me clear the environment before we start. Okay, so I'm loading the Tidyverse data and yeah, Tidyverse package and the data. Okay, so okay, now first part will be understanding the exploratory analysis. We'll be starting with part one. So here, first task is loading the and data set and use glimpse or structure to understand the data. Okay, so we'll be using glimpse of the data. Mm, and that will give us the glimpse of the data. Okay, so this is actually the glimpse of the data. So it actually giving us some information like rows. We have 19,573 37 rows and 13 columns are there. Okay, So we'll be using both of these things. So okay, so str and glimpse of the data. Now, okay, if you wanted to split this one, there is a shortcut. Either you can click on insert this one, insert a chunk, R chunk, or you can use Control Alt and I. So that will split or insert a new chunk. Okay, in R Markdown, if you need to execute some code, we will be putting those things inside a chunk. Okay, so okay, this is known as a chunk. Okay, this is known as a chunk. So this is basically three codes and then R symbol, and then in between we can write anything that will execute, and outside this whatever we are writing that won't execute, that will be considered as a text. Okay, in a markdown format. Okay, those who are new to R Markdown. Okay, now we got the glimpse of the data and structure of the data. um, okay, so we can write something after seeing the result here. We can write something as needed. Okay, okay, and 13 columns. Okay, so now the second thing is we need to summarize the data set. So okay, the structure of the data set, and then okay, and then we wanted to represent the missing values and all. Okay, so we can do. Okay, to check the data quality issues, what we can do is we can first check the summary of the data for checking if any values are missing. Okay, so here you can see. Okay, here this particular one having missing values, and this is having missing value, and here we have missing values, and yeah, here we have different categories for storm and all. Storm status. Okay, so there are particular values having missing values. Now we'll be checking call sum of is.na of data, so that will count the missing values in each of the column. So it will be after this. So here one, two, three columns have missing values. Categories having missing values, and yeah, these two variables having missing values. Okay, now okay, so that's how we will find the missing value. And variable type, we need to look at the variable type. So also class of okay, class of each column types, so that we will also get it in the glimpse itself. So here, yeah, glimpse is actually showing name is a character. Okay, and this is the name of the okay, let's open the data. So this is the name of the storm, so that is actually in a character format. So we need to investigate how many unique values are there, and based on that we need to convert it. Year is in character format. No, it's in numeric format. It's numeric, month is numeric, and day is integer. Okay, so that is okay. We can create a date variable as well, combining these three. Now hour is there, then we have latitude, longitude is there. Then we have status, that is a factor variable, and then category is there. Categories are missing, most of the values are missing in category. Then wind is wind speed, so that is there. Then pressure is there. Then these two things are there. For these two also, most of the values are missing. Okay. So okay. So first we will write this thing, for and okay. Category storm, type columns. We need to make sure those are on this one. Name column is character, which is appropriate, and we need date column from year, month, and better handling this one. And then which need to be handled. Okay, so we need to either handle the variable or drop the variable. Okay, drop the variable as the percentage is high. Also, variables. Okay, so these are few insight we have here. So based on the first thing. Okay, now what we need to do is we need to change the type of the variables, and also we need to check for the outliers as well. Okay. Um, Now first we will check the outliers of the data. So how we can check the outliers of the data? Can anyone see how we can check the outliers of the data? Anyone? Any thought? Okay, by using box plot. Any other thoughts? Any other thoughts? Okay, so Anaka, as you told, we can check for outliers using box plot. Okay, I'm just checking the outliers using the box plot for these two things, wind and pressure. So these are our main target variables. So I'm just plotting these things. For this one, okay, for wind speed, this is the box plot, and for pressure, this is the box plot. Anaga, if you don't mind, can you unmute? Or just mention like it's okay if you put it in the chat also. If possible, you can unmute. So what do you find here?
Sir,
Yeah, thanks, Anaga.
what, sir?
Yeah, thanks, Anaga. Okay, so how you identify the outliers here from this box plot?
So the points and
Hmm.
after the line, it's considering as outliers.
Okay, you are saying
It's,
points,
it's coming after the outlier.
these points, right?
Yes, sir.
Okay, and for this one, these points are below the lines.
Yes, sir.
Okay, so which of the data points actually representing this? Do you have any idea? Like, what are these points, or what from where, from which part of the data these are actually coming? Do you have any idea?
No, sir.
Okay, so as you mentioned, like you actually put it in the group. That's a good thing, uh, because others are not even responding. But most of the people actually think box plot is the method to find the outliers. Okay, so box plot is not a method to find the outliers. Box plot help us to make sure that the data has outliers or not. Okay, box plot will tell us if the data has outliers or not. But the main thing is, if you wanted to detect the outliers, there is a statistical way, or we call it as the IQR method. Okay, IQR method to identify the outliers, because most of the people actually making this issue, like, or mention this one. So we use the IQR method. IQR method is simply this one. So you might be studied it in your classes. So we will find the IQR. You know what is IQR, right? It's interquartile range. Okay. So okay. IQR is interquartile range. Q1, Q3 is there, and we will call the create the lower bound and upper bound using this format. Okay, so Q1, if I go to the visuals, okay, this is an easy way you can actually do this in formatting in R. So you can actually put points and okay, so it will be handled here. Now, okay, so basically IQR is the interquartile range, and Q1 represent the first quartile, Q3 represent the third quartile, Q2 is median, as you are aware. And from this one, we will calculate the upper bounds and lower bounds. Okay, that is actually Q1 minus 1.5 times of IQR. Okay, so here I will also mention how to calculate IQR also. Mm, IQR equal to Q3 minus Q1. Okay, this is how we calculate IQR. Now, okay, so IQR is Q3 minus Q1. So lower bound for outliers will be Q1 minus 1.5 times IQR, and upper bound for IQR will be Q3 plus 1.5 times of IQR. Okay, this is the upper and lower bound for the outliers for any data. Okay, and if you want to make sure that you handle the outliers, this is the this is the approach we use frequently. Or there is a there is another method that is based on C score. You might be heard about Six Sigma and all. So values beyond plus or minus 3 standard deviation from the mean, that will be considered as outliers. Okay, these are the two methods we have to handle the outlier. So using box plot, we actually finding out if there are some values that is above the upper bound or below the lower bound based on the IQR. Okay, this is actually the theory we are using in box plot as well. A box plot simply represent this one, but it won't tell you which are the values you need to choose. Okay, so for Q1 and Q2, we can find the values like this. Okay, then if you filter the values from the data, okay, we will be getting the outliers. Okay, so first we find the Q1 for wind, that is using the quartile function. Data wind, that is using the quartile function, we will find the uh, 25 percentile or first quartile for wind variable, and third quartile using the quartile function, and 0.75 for third quartile. Then we will find the interquartile range using Q3 minus Q1. And we will find the lower bound like Q1 minus 1.5 times IQR, and upper bound using Q3 plus 1.5 times of IQR. And okay, I will call it as data wind out. Okay, so okay, so we will do the filter from the data, like we will do the data, then using a pipe operator we assign the filter where wind greater than lower bound wind, and wind less than, sorry, wind less than upper bound of wind. This is the data that is not having the outlier. Okay, this is the data that is not having the outlier. Okay, no outlier. Okay, now, okay, so with this condition we can find out the data uh, wind out, that is the data having outliers in the wind column. So this is how we generate the data sets. Okay, this is how we found outliers and non-outliers. So here you can see 480 observations are having outliers when we come to the wind column. Okay, when we are considering the wind column itself, there are 480 observation that is having outliers. Okay, these are the data set having outliers in wind column. So that is not possible to extract from this box plot. Okay, so now if anyone asks you how to find the outliers, never tell them like box using box plot we can find the outlier. Okay, either we can use the Six Sigma method, or the most common method we are using in box plot and all, that is called IQR method, interquartile range method. Using that only we will be calculating the box plot. And just one thing, um, these are the kind of questions you can actually expect on your interviews and all when you are going for some opportunities and all. So we will be have some idea on statistics, but we will be missing some of the basic, very basic elementary level things. So that is one thing uh, that is actually uh, that is actually a factor that reduce your chance in your interview. Okay, be clear with the basic or elementary things. Okay, in statistics. This is a simple question, but yeah. So this is how we can find out the data. Similarly, mm, I'll keep this in the upper end and okay, the other end. Okay, cool. So this is how it works. And similarly, we can find the things in the pressure columns as well. Okay, so we'll be using the same method called okay IQR based one. Okay, so this is how we can find out the outliers in the pressure columns as well. So there is an alternative method that is using the C value. Okay, for your understanding, I will just explain this thing. So C score will be we can use the scale function to find the C score, and outliers we can find using which absolute C score win greater than 3, and based on that we can find the outliers. Okay, so this is the approach we'll be using based on the C. Okay. Uh, okay. So these are the value having outliers based on the C score. Okay. So you can see that there is a difference in the number of observations. So it is actually because we are using the two different approaches here. So here we are using the mean and standard deviation, and in IQ method we are using the median or quartile values. Okay, so that is why it is making difference in the number of observations as well. So using IQR method, we can actually cover most of the outliers properly. That's why in data analysis, we generally go for the IQR method. Okay, any questions here? Okay, any questions in these two approaches for outliers? Any questions? So it's clear. Okay, so nothing, no comments. I think it's clear. Okay, great. Now, okay, perfect. Thanks, Aditya. Okay, so now we found the outlier. So we identify the outliers and missing values from the data. So then that is actually covering two data issues and all. Now, mm, yeah, we have discussed variable types, outliers, and all. So we have discussed those things. Now, data transformation with a deep layer. So filter, we have already seen a filter using the outlier, but we cannot simply remove the data. We need to keep the data and treat the outliers. Um, Now we will see how we can do the data transformations and all. Okay, so we'll see that. Okay, now first thing we will do is we'll be handling the missing values in the category column by removing those rows. Okay, first we will see the missing. Okay, let's do this one. Okay, first we will find out the unique values in data category column. So let's see how many unique values are there. So in category column, we will be having mm, okay, where is category? We will be having these five values: one, two, three, four, five. That is the based on the wind speed and all. So okay, we can simply just table data category and winter. Okay, okay, okay. So here, this is the wind and this is the whole thing. So okay, so this is actually giving us these frequency table. But what we need is the aggregate values of the average of these things. So for that, we can actually use the aggregate function. So uh, okay, aggregate function we will be use. Okay, okay, data wind by list category and function mean. Okay. So using this function, we can actually find the aggregate values of this column. So here you can see for group 1, average wind speed is 70 kilometer per hour or 70 knots per hour. Okay. For category 2, average is 89 knots per hour. And category 3, 104, category 5, 121, and category 5, 146. Okay. Now, if you look at the missing columns, okay, missing column cat in category, this much values are missing. Okay, so we don't need to remove this column because we can actually find the information from the wind column. Okay, we can actually find the information from wind column. Mm, we can update the category using the wind column. Okay, so this is how we can find out if we need to remove any columns or we can treat the missing values in some way. Okay, so we don't need, instead of removing the category column, we can update the category column using this condition. So okay, so here we have mean, and similarly we can find the maximum and minimum value. So okay, so based on wind speed, we can. Sorry for that. Okay, based on the minimum and maximum speed of the wind inside each category, we can we can update the category column. So for that, we will be using the mutate function, and we will be using the case when. So if wind greater than 64 and wind less than 83, then we will be put 1. So first we need to find these min and max values for each of the column. Okay. Okay, we'll be using the summarize function to find the maximum and minimum wind speed based on the category. Okay, so we'll just execute this one. So mm, okay, so here you can see okay, category 1, minimum speed is 65 and maximum is 80, and for 285 and 95 like this. Okay, so based on these values we can create a column. Okay, 65 and 80. So and next one will be starting from 85. Okay, so we'll keep an in between value like this. If wind greater than 83 and wind less than 96, so second category will be, yeah, 95. So we'll be keeping 96, and third one will be 100 to 1. Okay. Okay, now we can update the data set like this, and okay, we can verify the changes like this. Okay, now if I execute this one, okay, let's split the column here. Okay, so okay, so I'll be getting this values here. So this is the categories, and yeah, let's put this one. What happened? Campaign, right? I'll put category one, and let's see. Right. Character and okay, so category is a character variable here, so that's why we cannot update this using this one. So uh, no, no, it's true only. We put it as category. Wind speed is in this numeric only. Yes, it's right only. Right. Can combine between character and double. 1, 2, 3, 4, and 5. This is category only. Then let me see this if that is making an issue. Yes, so that is making an issue. So yeah, so okay, so here okay, so here I put this one. I put category here. If true, that is category. So that is actually making that issue. Mm, so what we can do is, so here we have category. So stored we'll be using as dot characters of category. So I think that would work. Let's see. Yeah. So here it actually work. So here you can see now all the values are actually captured here. So this table value still give us the frequency count like this. So what I prefer is using the aggregate function. Okay. Um, yeah. So using the aggregate function, we can see that. Okay. So here you can see only five values are there, and this is actually calculated properly. Now call some. Okay, we can check if there are any this one also character. Okay, so while checking the call sums, we can see that in category this much missing are there, and oh, still in category one also this much missing. Category one has to that is not possible now. So 14, 5, only few are mapped. Okay, NA values will be differ from 0, 10 to this one. Okay, we can call this. Let's put a this thing like 0 when it is actually between. Here we took 64. Um, winter winter greater than 10. That is a minimum value, and wind less than 64. Okay, so we'll be putting a new category that is 0 when it actually between these values. Okay, so now you can see category 1 is actually 0. We have added one more category. Okay, so one more category is there, so that is 0 if the wind is between 10 and 64. Okay, so that is not considering here. Or okay, so that will be keeping us a category. Now okay, now this one is still a character variable, still a character variable. So we don't want to keep this as a character. So we wanted to change it into a factor variable. As it is a factor, it is having some levels only. So we need to convert it into a factor. So we can do it here itself. So we can do as dot factor, as dot factor, and we can complete it. We can change as a factor. So here, okay. Now we have changed this to uh, and combine the missing values. So okay, now our data. So the data category will be sorry, category one will be there. Category one will be a factor variable. Okay, so here you can see it's a factor. Now we have updated that one, and we don't need the this one also. We don't need okay. Now we don't need the category column. So what we will do is we will okay, sorry, we will remove drop column category, and we will also rename. Sorry. Okay, we will also rename the variable. Okay, rename new category to the category. Okay, so here we only need this one. So we have updated that one as well. So now we'll run this one. So let's see. Okay, now this is category. Oh, it is already removed. I think I need to execute everything till here. So this is an option. We can run all the chunks till here using this one, and now we can execute this. Okay, if you find any mistakes, if you are applying the same data names, then you can find this mistake like this. Okay, okay. Now we have the updated data. So here we have updated the column stat category. Okay, now category is updated, and now okay, we have updated this one. Now the next task will be okay. So here, okay, it's in bold letter. We can put it in this way. Okay. Now we need to create new data frame called this one that only include observation where status is hurricane, and year after this one. Okay, now we can do that one. So we have handled the missing columns. Okay, now we have a couple more missing columns, so we will work on that as well. Okay, we will see the relationship between with the columns. Okay, so these are the two columns that is missing. Um, does it have any relation with the wind speed and pressure? Okay, okay. So first we will check how many missing values are here. So this is the number of missing values here, and okay, I maybe best to drop these columns from the data set for the analysis. And now before that we will also check. Okay, before that we will also check the relation with other columns. Okay. Okay, so we'll check the relations if any relations are there with this one with wind and other one. So there are a lot of values are there for these values. Okay, some 140 unique values are there. So let's keep okay. Let's check how many unique values are there. So we'll put the sum function as well. So it will give us the sum. Oh, okay. Okay. We'll check the length of unique, so it will give you the unique values. So 142 unique values are there in this one tropical storm force diameter, and then for Hurricane force diameter there is 43 unique values are there. So we cannot directly find the missing values from the aggregate. That it's not a category. So we will plot the relationship between these columns. Okay, it's already there, so otherwise we'll split it here. Okay, so we'll be using the ggplot function. Ggplot is actually help us to find. Okay, ggplot will help us to find create a plot in R. So we will using ggplot, and we will pass the data. Aesthetics we are passing. So we will be explaining ggplot in detail in the upcoming session. So I'm just giving an overview. And here we are putting the yeah, x-axis will be tropical storm force diameter, and y-axis will be wind. And we will be creating a scatter plot. That's why we are using a geom point, and we will be giving some labels and all, and with a minimal theme. And another one we will be using the same for Hurricane force diameter with wind speed. Similarly, we are creating one for the pressure as well. Okay, and we'll be creating the same for Hurricane force diameter as well. So these are the four plot we are just plotting to see any relations are there. Okay, so these are our plots. Okay, this is actually the tropical storm force and diameter wind speed. So this is actually um, does not find to have some relationship, but with pressure you can see some relationship is there. With pressure, some relationship is there. As it is not categorical, we cannot directly map something like the previous one. So we need to go for some advanced versions. Okay, now okay, these are the values having this one. Now, what we'll be doing, we will check. Okay, we will check if there is any relationship of these variables with the other values as well. Now, for that actually, we will be okay. So based on this scatter plot, there is doesn't appear any strong relationship between wind speed or pressure and force diameter columns. Okay, so these are not so in that case it's not giving a good assumption, or not contributing something to the analysis. But still, we'll drop this column for the analysis now for the entire data analysis, but we'll see if there is any relation with um, okay, we'll see if there is any existing relationship with wind name and name for this variable. So okay. So first thing is we will be seeing the wind name and okay, what is the data here? Okay, okay, name and okay, let's see the unique names as first. Okay, so this many names are there. So okay, 260 unique names are there. So it will be difficult if we check for these things. Um, Now we'll check if there is any name Hercules uh, or topical storm. Okay, so first we'll create a table here. Mm, Hercules is there, so there will be some relationship with the status. Okay, so it's not with the name, so there will be some relation with the status. Um, Now we will see the status, unique status. Okay, so these are the unique levels in status. Okay, okay. So here it is clear that the storm names have both Herculean and tropical storm status. So we'll be okay. So for we'll be checking the relationship with wind or pressure with storm status. Okay, okay. Instead of storm name, we can check the relationship with the status. So here I'm just removing this thing. Um, okay, length of unique data set status and okay, we'll see these things. One is what are the unique values there and total unique values. Then we will see the relationship between winds and pressure with status also. So first thing is the unique levels. 9 unique levels are there. So it's already a factor. 9 levels are there. So average or things are like this. So there is no direct relationship with this one. Uh, so here also it's not seems to have some direct relationship with this one. Now uh, we'll see if Herculean status have uh, this column having some value. Okay. So there is no direct relationship between pressure, window pressure with status, and we'll keep the columns as it is. Now we'll check if the okay. So we will check if there is any relation with this one Herculean and um, status value. So we will see that one. So let's check that. Okay. So you can see Herculean and extra tropical having some relationship with this column. Um, okay, so that is this diameter, force diameter, have some relationship with Herculean and extra tropical values. So it's somewhat related to these status only. Okay, so these variables are with the status only. That is somewhat related to the status. Okay, it is not directly having any relation with other variables. It's having some relation to these categories or these statuses only. Okay, so that is one insight we are actually finding from the data analysis. So here it is clear that there is a relationship between Herculean force, diameter, and status. Herculean, but since the columns has any missing values, we'll drop this column for the analysis. But uh, okay, so I will keep okay, I will keep it as a data dropped. Okay, so I will drop this to data set, and yeah, we'll check the data set once again. So these are the variables we need for the analysis, that is having some details and all. There is no missing values and all. So this is the data we need for the further analysis. But for this particular task, there is one task, we need to create a new data frame called Herculean subset, that only include observation that has Herculean as status. Okay, and year after 2000. So we'll stop this data analysis part here. So we also have the data dropped one is there. So data transformation with dplyr, we'll check those things first. Okay, now we'll do the filtering and slice. So we'll be creating Herculean subset uh, from data, not data dropped. I have created that for the analysis, and it will be filter the status Herculean, and okay, it will filter the status Herculean year greater than 2000, and we will only need these columns. Okay, so that is a task. Okay, only this much, and we'll be taking the head of the data, okay, to see the data. So now we have the Herculean subset that is having 2500 observations and 6 variables. Okay, and with the necessary variables only we have selected. Uh, okay, and the head of the data will look like this. Now, this is the one task we have here. Second one is mutating the data in your in your subset. Add a new column called wind kilometer per hour that convert into this. So we'll be going for that one. Task 2, that is mutating. So There we create a Herculean subset, and this data set only we are creating the new column using the mutate function wind kilometer per hour. That will be this one. The formula is already given, so I will be using the formula directly. Okay, and okay, so once we run, we will be getting the data with the updated wind kilometer per hour. This is the wind in knot, and this is the wind in kilometer per hour. Okay, so that is completed, and now we have the next one, summarizing the data. So for that, the task is simply identify the storm of the century for each year since 2010. Calculate the maximum wind speed and minimum wind speed record for each storm name with those years. Okay, so that is the next task. So we will filter the year greater than 2010 and group by name and year. And because we need it based on the name and year, we will summarize it. We need to find maximum wind speed and minimum wind speed, minimum pressure for each of the categories. Okay, so we will be arranging it in, with the year and descending out of the maximum wind speed. So, and we will be taking the head of the variable. We will be displaying the head of the data set. Okay, so this is the maximum wind speed and minimum wind speed. So this is the data storm of the century. So we'll be having based on year and name, we'll be having 229 records and four variables. That is like this. Okay, so uh, that is there, and okay, that is for the tasks till 2.3. So any questions here? So any questions or any doubt till here? Any doubt like why we need why we go through all these steps, or any of the steps is unclear? We need to explain once again, or why any of the steps is necessary, and also any questions like that. Any questions? Could you explain the frequency table that was created earlier? Aditya, which frequency table you are mentioning, referring to? These one using aggregate or using the table function? Last missing value part. Last missing value part is this one. Um Categories and wind engine. Category and wind. Okay. So here we had some values that is yeah, that is having a category that is missing. So we wanted to check. So ideal thing is we need to drop this variable because most of the values are missing here. Okay. So but still this category is giving some kind of information to the data set. So we cannot directly blindly we cannot remove that variable. So that's why we are just investigating on the data how it is related to another variables and all. So basically this is actually what we do in a data wrangling process. Or once we get the data, we will thoroughly investigate what are the possibilities before handling or before blindly dropping a variable, or before assigning some missing values, missing value treatment or so. Okay, so this is the first step we are using to handle the data. Okay, now uh, so for that one, okay. Yeah. So handling the missing value in category column, for that one, we first check the unique data categories that is having okay, 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 a unique data category. So that will be having values NA 1, 2, 3, and 4. 4, 5. Okay. So these values were there. So here a lot of missing values are there. We already seen the number. It is more than 14,000 record. Okay. Um, Now we wanted to see how this is actually related to. Is there any relation with wind? Okay, wind speed category does have any relationship with wind speed or pressure? Because as per the data, wind speed and pressure are the two key target variables we need to investigate. Okay, that's why we just look at the category and wind speed. So here we use the table function. Table function will give you a frequency table of the values we are providing, or on the columns we are providing. So I need a frequency table for data category and wind. Okay, category and wind. So I use the table function. So here I got the table function. So here in rows I have the category elements, and in column I have the unique values of the wind speed. Okay, wind speed, unique values of the wind speed is there in the columns as well. Okay, you can see it is varying from 10 to 165. Now, for each category, you can see some of the values are how many values are there. Okay. For example, here, if you look at 5, the category is 5. Then in category of 5, it is actually starting from 140. Okay. Till values 140, no values are there. It's all empty. So from 140, it is taking the value 140. 40 elements are having 40 elements in the category 5 having the value 140 or wind speed 140, and 32 element having have values 145, like that. And if you look at category 4, 80 elements, 80 observations have value 130, or 40 observations have value 135, like that. Okay, in each category you can see. So here you can see from a category from value 65. Okay, only it is starting to a category, or it is assigned to a category. Now there are other values as well. So there are values from 10 to 60 that is not assigned to any of the columns. So now we can so this is actually giving that information in a frequency table. Okay, how many counts are actually there. Now, this is a category. Wind is a categorical. Sorry, wind is a continuous variable, and category is a categorical variable. So, I cannot investigate all these values individually. So, what I'm doing is I'm using the aggregate function. Aggregate function will help me to aggregate is kind of a summarize function, but it will aggregate it for two variables and all. We can use the aggregate function. That is an easy one. And in aggregate function, I'm using the data wind. Okay, wind is my target variable by list of data category. Okay, so I'm taking data category as list or a group variable, and I need the mean function. Here I am using is mean. I need the mean of data wind variable. Okay, wind variable mean I need by the group of category. So I am using the aggregate function. Aggregate target variable I am putting, and group by variable I am putting, and then I am mentioning what is the function I need. And here a lot of missing values are there. I am putting an dot remove equal to true. Now this aggregate function will give me the aggregate values of the averages of each category. That is removing the missing value. Okay, so okay, I got the average values here. Now I also need the minimum and maximum values as well. So I can use the different aggregate function for minimum and maximum. So instead of that, I'm using a summarize function as well. Okay, so here I am grouping by category. So these are the average values that is having an order. So that's why I'm using the minimum and average, sorry, minimum and maximum values to find the details. So I'm creating that WinStat minimum and maximum value. I'm taking the great data, grouping by category, and summarize by the minimum and maximum. Okay. So once I execute these things, I will be getting uh, each category wise minimum and maximum values. Okay. Maximum wind speed. Okay. Some of the values are missing. So from 10 to 105, some of the values are missing. Um, okay. So here we have a clear pattern for these things. So I'm just assigning whatever is missing. So I'm just assigning these values based on the minimum and maximum speed. So minimum and maximum speed, if it is less than greater than 10 and less than 64, because from 65 we'll be having category 1. So whatever is between these things, I'm just putting those things as a new category called 0. Okay, and the remaining thing I'll be assigning based on the minimum and maximum value. So here why I use 64 is I need to include 65 also. So that's why I just use the 64. If there is something 64.5 or something is there, I can include it in 65. Okay, so that's why I use 64 for a safer side. And 83 because it's stopping from 80 and starting from 85, so I'm using a mid value. Okay, a value in between for a safer side. Okay, if sometimes other values are comes in and there is no rules assigned, so I'm taking some of the values closer to the minimum and maximum. Okay, so like this I created all the 5 categories, and if any of these conditions are not taken, that will be taken as dot category. And here I take the category 1 as new variable, and then removing the existing variable and renaming the variable. Okay, so I have the new data with no missing observations. Okay, this is what we have done. Now you can see by aggregating function again, we have all the variables that is not missing. So, and while taking the call sum also, I'll be having category with no missing values. Okay. Is it clear? Is it your question and it's clear? Okay, great. Yeah, thanks Aditya and Anaka for putting. Okay, now we have these things, and here you can see that there are some outliers in the data, but I didn't make any update on the outliers. Why? Because that outlier is necessary, because we have different storms and different category of storms. So that outlier is necessary for this data set. So that's why I'm not treating the outlier, because that outlier for the analysis purpose, outlier is necessary. So I'm just keeping the outliers as such. Okay, every time we don't need to remove the outliers. Sometimes the data or analysis demand that one, so we need to keep that one. Okay, perfect. Okay, now we have till part 2, and now we are reshaping the data with tidyr. So first one was pivoting. We need to pivot the data. So the task was okay. Suppose you wanted to compare the distribution of wind and pressure across different storm categories. we can transform those into two numeric columns into a single column and called metrics, and their values into column called value. Okay, so now we can use a pure longer for that one. Okay. So I'm putting data long and taking the data using the pivot longer function, and columns, I'm taking the columns wind and pressure to rows. Okay, and the names, these names I'm taking, these column names I'm taking to a column, new column called matrix, and corresponding values I'm taking to values. Okay, a column called values. Now head of the data long. Okay, if I run that, I'll be getting this one. So here, mm, we have 13 columns, and okay, other columns are there. So let me open this one, data itself, data long. So here you can see the observations are double. Okay, 19,000 observations was there. Now 39,000 observations are there. The observations are doubled because we changed that one. So here you can see, now instead of wind and pressure, we have a column called metrics and value. So corresponding to that, we have metrics and pressure. Now, we need to see the relationship with this one. Okay, so we can use a ggplot to plot that one. So okay, if I plot that one, so I'll be getting a distribution of wind and pressure using this one. Mm, now, okay, so usually we will go for the box plot and all for the distribution, but actually for outline and distribution visualization, we can actually have a better plot that is called um, the violin plot. Okay, that is also available in ggplot. So instead of box plot, I'll be using the violin plot. Okay, so instead of box plot, I can use geom violin, and it will create a violin plot. So you can see the violin plot like this. So it will show the distribution properly. So here it is in two different dimensions. So that's why it's not showing it properly. I will show you an example of this one, only considering the um, instead of data long, just taking data and sorry, wind and this one and category and wind. So let's see. So here you can see how the values are distributed as well. So here, if you consider this one, see the category. Um, this is from 0 to 60, somewhat around 60. So you can see most of the values in 0 categories are between these points. Okay. So in between actually 20, okay, 20 to 30. So in between those area actually we can see most of the values are scattered. And if you look at the category 1, most of the values are close to the 65 related to that. Okay, we can wait, and here if you took at matrix 2, it is mostly close to 90 and all. Okay, so if you wanted to check, you can actually check it with the previous one that we have. Okay, here. Okay, mm, not this one. So not here, not here. Yes, here. So if you look at the category, yeah, category 1, you can see most of the values are close to 60. Okay, so that you can simply understand, identify by this one. And most of the values in category 2 are close to 80 to 90. So those kind of things you can actually see here as well. Okay, uh, you can see here as well. Okay, in this plot. So nowadays we are not using the blocks plot. We are mostly using the violin plot instead of box plot. That will give more information about the yeah, more information about the distribution as well as the outliers in the data. So here, if you look at here, you can see some outlier values are there. That is very sharpened points. Here also you can see some outlier points. Okay, that is very sharpened in the plot. Okay, so those will be outliers and other things will be the distribution. So this is the more advanced plot we are currently using instead of box plot. Okay, this is the advanced one. Now we have the relationship between the matrix and pressure, so that is here. Mm, Now, okay, next task is to unite the values. So okay, unite the value, using the unite function we can create a new column called date id, combining year, month and day with a hyphen. So we can simply do that as well. So I'll be creating a call data called data united, and united call will be date id, and it will be year, month, day separated by a hyphen. Okay, and we'll be seeing the head of the data like this. Okay, so now data united will be here. Sorry, data united will be here. So we'll be having a column called date id, and yeah, so date is actually combined. Okay, three columns are combined into one column called data id. Okay, so that is how we use the unite function as well. So this is the kind of task we already had. Apart from the given things, we have checked couple more things, and I hope that help you to understand the data wrangling process and how we read the data and understand the data and make it ready for the analysis and all. So here, if you have some uh, objective to the analysis part, this is just the data wrangling part. So if we have some objective to the analysis part, some testing or some modeling we need to do, so those things we can also do. Yeah, based on these all these data set, it's not depending on one single data set that was given earlier, and we are not making all the updates in a single data. Okay, okay. So I think that is covering the entire task we have. Okay, if you have any questions, you can please feel free to ask. So now we have a report like this. Okay, so this is the report, entire report we have with all the necessary things and all. And even if you want, you can create a Word document. So along with the HTML, I'm creating a Word document as well. So let's open that as well. Okay, so I'm getting a Word document as well. So as needed, you can simply make the necessary updates and changes, and also and after that you can simply share it. Okay, so this is how we use the markdown, and we will discuss the markdown and all in a detailed session later. Okay, so this kind of formatting and all you can still do with Word document. So every code and everything will be there. So you can see the code and everything is there, output code and all, with all the comments and all, everything is there. Okay, so any questions so far with this task and this analysis? Anything? Any questions so far? Okay, any questions so far? Okay, if there is no question so far, then we can wind up the session for today. Okay, and